To date, the GigaPress is the world's biggest die casting machine of up to 61,000 kilonewtons and can weigh up to 430 tons. Furthermore, these massive die casting machines are the size of a home and can release exceedingly enormous components. These machines are currently solely made by the IDRA and LK Group. Tesla is the first corporation to place an order for the GigaPress, and ever since this order has been placed, the tech world has been looking forward to it. Today, we'll be explaining all about the GigaPress, so let's get started. But first, let's take a look at the past. Riccardo Ferrario, the IDRA Group's general manager, was the first to create the term GigaPress in late 2018. Tesla didn't start utilizing the modified OL6100 CS GigaPress for manufacturing until late 2020. However, IDRA had previously declared on their website that the first order for a 5,500-ton high-pressure die casting machine had been received. Tesla's president of automotive, Jerome Guillen, revealed in 2019 that the company is working on a huge, giant machine to produce full-size automobiles in the same manner that miniature cars are created. Elon Musk later revealed in April 2020 that Tesla had purchased two massive die-casting machines to produce chassis parts for the Tesla Model Y. He said that it was the biggest casting machine ever created in a tweet in August 2020. Elon Musk also revealed in January 2021 that the Tesla Cybertruck's rear chassis would be cast using a GigaPress with a clamping power of over 8,000 tons. Tesla has also completed the installation of 3 GigaPress in Shanghai and 2 GigaPress at its Fremont manufacturing plant. We believe more firms will use the GigaPress technology to improve their production efficiency in the future. The GigaPress resembles a die casting setup rather than a machine. It is outfitted with all of the necessary devices and systems for die casting. Tesla's GigaPress has the following components. To begin, there are 2 ovens in the GigaPress that handle the aluminum alloy. One is a melting oven that runs on natural gas and has a melting temperature of 850 degrees Celsius. Another oven, powered by electricity, also runs on 850 degrees Celsius and stores the liquid metal. The second component is the GigaPress itself, which is the heart of the whole arrangement or die casting machine. It's built in the same way as standard high-pressure die casting equipment and works in the same way, only it's massive. The third component is a vacuum tank, which is needed because the GigaPress creates a vacuum within the mold with a 4,000-liter tank. Fonderex, a Swiss business that started the vacuum technique for high-pressure die casting, manufactures it, as well as many other components, like a quenching tank, a trimmer, scrap metal recycler, and devices for inspection like X-ray machines to inspect the finished casting. The way the GigaPress operates can be explained in the following steps. First, all materials need to be prepared, which is where the aluminum ingots and cutoffs from the last casting cycle get melted in an oven set to 850 degrees Celsius. Then, using heated pipes, any impurities are removed from the surface and the liquid metal gets transported into another contained oven. The production of oxides in the molten aluminum is prevented by filling space within the storage oven with nitrogen gas. It also aids in maintaining a consistent temperature. Operators utilize argon gas, a rotary degasser, and a silicon carbide filter to remove even more pollutants. The next step is the die preparation. That starts with a robot spraying roughly 35 milliliters of soybean oil in a thin layer to make casting separation simpler. The vacuum system then provides a vacuum pressure of approximately 50 millibars inside the mold cavity. The actual casting starts when the molten aluminum is sent from the holding oven to the GigaPress's shot chamber. A high-speed plunger is used to drive the molten metal into the cavity. Before each shot, the plunger is greased with 8 milliliters of oil. The casting is left within until it hardens after injection. At 400 degrees Celsius, the casting is discharged from the dies. After that, the raw casting is placed in a quenching tank to drop the temperature from 400 degrees to 50 degrees Celsius quickly. It aids in the removal of some flaws and the enhancement of some material qualities. At the end, using a mechanical trim press, each casting is cut into the desired measurements. The scrap aluminum is recycled and reused in the oven using a scrap metal shredder. The primary casting is next inspected using an X-ray machine to see whether it has any interior flaws. The validated casting is further improved using a laser trim and drilled with a CNC machine for fittings. Finally, the precision of the model casting is verified using a coordinate measuring machine. The Tesla factory in Fremont and 3 gigafactories in Shanghai, Berlin, and Texas are currently the only locations where the GigaPress has been built or deployed. With the GigaPress technology taking form, we're expecting new possibilities. We can already see the promise of this technology, even though it isn't fully developed. The GigaPress has several advantages, which we've covered here. The GigaPress will significantly increase the efficiency of large and complicated production. This will enable manufacturers to cast a considerable component rather than a series of smaller pieces. Therefore, the assembly process will be essentially eliminated. As a result, significant time, labor, and ultimately manufacturing cost reductions will be realized. Casting a more significant single piece will allow the manufacturer to create a lighter structure while also increasing the casting strength. In addition, casting a single component eliminates the chance of part alignment difficulties during assembly. Quality control will be simplified, and manufacturers will produce high-quality castings. Furthermore, it will lessen the demand for robots in manufacturing and the size of the assembly line. As a result, there will be cost reductions in terms of land utilization. Currently, automobile castings appear to be the GigaPress's most common use. Automobiles have complicated parts that are made up of tiny pieces. Reducing the number of castings to a few molds would enhance manufacturing efficiency considerably. The GigaPress is being used by Tesla to cast the Model Y's rear body structure. It will combine 70 separate castings into a single unit. They want to use the GigaPress to cast the front chassis component as well. It has a significant impact on our perceptions of contemporary manufacturing methods. Given that this is a relatively new technology, it may be long before we see further applications. We expect to see the GigaPress used in more imaginative ways in other sectors as well. Mega casting is undoubtedly an intriguing notion. However, many people are skeptical about the technique's long-term viability because this is a new technology, even though there are many studies on the efficiency, cost, stability, and dependability of the GigaPress. When it comes to accepting a new notion, the industry has always been wary. As a result, other manufacturers may take some time to catch up on the massive casting trend. So far, we've only got a limited amount of information from Tesla. The rear chassis of the Model Y has been successfully trialed by Tesla. It's evident that they had to go through several revisions to get there. However, when manufacturers develop a better understanding of the technology, the design process for megacasting should become more accessible. However, handling such a massive amount of aluminum at once necessitates particular caution. During manufacturing at Tesla's Fremont facility, a GigaPress caught fire. The fire was started by molten aluminum and hydraulic fluid, according to the Fremont Fire Department. Fortunately, it wasn't anything significant and no one was in danger. As you can see, there are several hazards associated with megacasting to consider. However, we feel that as this technology advances, we will be able to solve the problems. In most circumstances, manufacturing a more significant casting should be advantageous in terms of efficiency and cost. However, depending on the application and specific conditions, the pros and cons may alter. Casting more prominent single components for autos, for example, has obvious advantages. However, before an accident, automobile repair and maintenance might be challenging. Because of slight damage, you wouldn't want to rebuild the entire front or back chassis. Automakers interested in the GigaPress may need to solve difficulties like this before pursuing it. That concludes today's video. Thank you for watching it all the way through, and please remember to like, comment, and subscribe to our channel. We'll see you next time. Goodbye.